Hello everyone, welcome to our channel. Today's video is all about container probes, and this is the second video in the video series of Getting Started with Kubernetes. And if you haven't watched our first video in this series, I recommend you to go first watch that video and then continue with this video series. I have also included the video link in my video description below. Moving forward with the today's discussion on container probes, the first thing we're going to talk on what are the prerequisites. So the prerequisites for this video series is container basics. So it's always good to understand the container fundamentals, and it's good if you have container fundamentals and then watch this video. You will better understand. So if you'd like to learn more on container basics, there is a post on our blog, osgroup-techies. So I'll also be including this particular link in the video section along with the first video. And it's also good to have Docker basics and Kubernetes basics. As I said, I have already included the video link in the description section below. So maybe you can go ahead and watch that video first and then continue with this video. Talking on agenda, so we are going to talk on few things today. So those are, first thing we're going to talk on what are pods, a basic recap so that we all are on same page and it becomes a little refresher. And we're going to talk on pod lifetime, what is a pod phase. We're going to also talk on container states. We're going to talk on container restart policy, container restart probes, container probes, and pod termination. So this is all we are going to talk on, and at the end we're going to include a demo which actually have these theories put into practical. So we are going to talk mostly on container probes. Our demo will be on container probes, but since our probes needs these few supporting theories and concepts, so that's the reason we are having this in place. Moving forward, so what are pods? Okay, so pod, I could say pods are basic unit of Kubernetes. So as we might have heard this term, right? So pod is like, it's a basic unit of Kubernetes, as I already said. So it's a most smallest unit of compute that you can deploy, and you can actually create and manage it with Kubernetes. You can also see a pod. We already have understood what containers are. So pod is logically, it's a group of one or more containers. You can say it's a group of one or more containers with a shared storage and network resources. So you have containers, and then when you actually logically combine either one container or more container, and then you make sure that your storage is being shared, your network resources are being shared. That means that if you have a two pod, they share the same IP. If you have a two pods and they have a volume mounted, they even share the same volume mount. So that's what it means, and that's actually what pods are. Yeah, so little more on if you want to know more on containers, as I already said, it is like in that section which I have mentioned. So it gives you more information on what containers are, and then when you go to pods, then you understand what pods are. So pods actually manage containers. I mean, like pods are like, it's grouping containers, and then you're giving they also like, for example, they run your containers. And then when you have your pod, and if you have more than one container, so it's always made sure that they are always co-located. So that means when they are scheduled to a node, they always sit on the same node and they run in a shared context. So shared context, in this case, it will be your namespaces, your C groups. So this is like they share this. For example, you can say, they share the process namespace, they share the network namespace, and they share all the namespaces, and it can be any other facet of isolation. Yeah, so this is what it means. So now by now we have understood, right? So what are pods? So pods are smallest deployable unit in Kubernetes. You can create and manage pods. So you can create and manage pods in different ways, either directly by pod API object, or by stateful sets, or maybe by deployments or some other controllers which is built on top of pods. And we also understood pods. It's like it actually at the end or what runs is containers, and then you can actually logically you're grouping one or more containers, and then you're making sure the containers which run inside a pod, if they are multiple in number, they share they share the resources. It's like you're having two processes on a local host and communicating with each other on a local host with localhost. Like, so when you say localhost 2020, but making sure that they are on two different port numbers, they do share the IP address. Okay, so moving towards pod lifecycle. Yeah, so pod actually follows a definite lifecycle, a defined lifecycle, where it says it starts with a pod phase. So when it starts with a pending phase, and then it moves through a running phase when one or more of your containers in the pod, they actually starts running without any error, and then it moves to succeeded phase if it actually is terminated with a success, and go to fail state if it's terminated with failure. Moving towards pod's lifetime. So pod has a life cycle and it also have a lifetime. And so what is a pod lifetime? We already understood what are pods. Now we're going to talk on lifetime. So we also have a few concepts clear that containers are ephemeral. So like containers are ephemeral, even pods are ephemeral. So pods are ephemeral means they are not durable. So if you have a pod, if you have a container, let's say if you have a container and then your data doesn't persist between the restarts or between deletion and creation, that is ephemerality. Pods, when they are created, they are created with a unique UID, and that remains unique throughout that context. Yeah. Pods after being created. So when there is created, so when does a pod get created? When you actually give a pod request. So when you give a pod request in any of the forms, maybe you give a command to a Kubernetes cluster, that in this case it is an API server. When you give to API server, and then it actually, what it does, it actually creates the pod as per your specification, and it schedules to your node. And then when it is scheduled to your node and it starts running, it goes to its different phases. That is when it goes in pending phase and it starts running, and it remains there until and unless it is terminated. So that termination can be done, that can be in any of the ways. That can be because of your resource contention. Maybe your resource is like your node is taken under maintenance, or your resources on that node is out of memory, and then your operating system on that node is trying to kill it, and then it actually remains there. So after that, it dies. So that is what the pod lifetime is. Few pod facts: pod do not by themselves self-heal. So this is self-explanatory. So when you actually go ahead and delete a pod, it doesn't come up by itself. So you have to create it again. So that actually self-heal is actually achieved by controllers. That can be any of your controllers, that can be even deployment or replica sets, which actually is being used by deployment. At the back end, it can be stateful sets or daemon sets, any of these. Pods do not survive eviction. So for example, for some reason your node is actually evicting. That can be any reason. That can be resource crunch, or maybe because of a new policy you applied for maybe affinity, maybe that is like different concept. So it doesn't survive. So it actually is deleted, and after that it is not by itself put to a different node. Yeah, and pods are never resolved to a different node. This means that when your pod is being created and it gets a unique UID, right? And then, for example, if it is scheduled to a one node, and then what you're doing is you're putting a node selector and scheduling it to different nodes. So what actually, or maybe you are having a deployment, and for some reason you're having that self-heal property, and you're going to delete on one node, and you want to create it on another node. So, and you get a template of another, you get a pod running on the different nodes. So that doesn't mean that your pod, which was actually created for the first time, it's same pod is going to being rescheduled to the different nodes. So that doesn't mean, that just means that a new pod is created from that pod template in that specification, and then the UID of that both pods are different. Okay, so in our pod lifecycle, we were discussing about different phases of a pod's lifecycle, right? So pod lifecycle contains of a phases, and then what's a pod phase? So pod phase is at a high level, it's a high level summary of your where exactly your pod is in its life cycle. That's what it actually says. So pod we understood, and phase is that one. And then starting with the pending phase, we already talked. So pending phase is like when we understand your pod is being scheduled. I mean, maybe it is being scheduled. So the pod remains in pending phase when it takes time. So after submitting the definition of your pod, it actually tries to find a node depending upon different criteria, depending upon the resource which is mentioned for a pod. And then once when it meets the criteria, the pod gets bound to a node. After bounding to a node, it starts pulling the image which is there, which is defined in that pod spec. So this total time the pod is in pending phase. And after your image is being pulled, and after pulling in, your container starts. So if at least one of your container inside the pod is in running state, your pod is in running state. And then it goes into a succeeded state depending upon, so if your pod, or at least one of your pod inside the at least one of your containers inside the pods, or all of your containers inside the pod, they exit with success exit status. They are in succeeded phase, and they do not restart. And similar goes with for failed. That is like it doesn't terminate with a success exit status. And now talking about unknown states, so your pod comes into unknown phase when for example you have a pod which is settled to a node, and for some reason you are not able to reach out to that node, and your kubelet is not able to send the state or phase of that pod, then it goes into this particular phase. Yeah, so this is like what we have understood on pod phase. Now moving forward, yeah, so we have talked till now. We talked what is pod, what is pod's life cycle, what is pod lifetime, what is the till where it lives, and then after that we are also talked on pod phase. And then similarly, as you know, right, so there is a component in kubelet which stays in control data plane, and then what it does, it actually keeps the track of the pod phase. Likewise, it also keeps the track of your container states. So what are container states? So you already understood what are containers, right? So containers are like your it's like you can say it's a C groups plus namespaces, and C groups is like control groups, which means that you're grouping of a processes and putting constraint on them, and then again a namespace is like you're putting isolations, right? So let's say that once the scheduler assigns a pod to a node, and then kubelet starts creating the containers for pod, right? So the main purpose of the pod is kubelet is to check that specification and read that, and then accordingly it starts creating the container. And then there are three possible states that like in which your containers can be. The first one is waiting state. What is waiting phase? So if a container is not in either running or terminated state, so like for example you saw, right, so what is like the running phase, and there is like after pending it goes in running, and then it goes in terminated. Depending upon if it is terminated in success, it is succeeded. If it is in failure, it is failed. So if it is not in either terminated or running phase, it is in waiting phase. Yeah, so for example, sometimes, right, you have a container and you have some prerequisites to be done for that container. Maybe you have a secret secret data to be like for example you have you want to log into that registry, and you want to pull the image, or maybe you want to query the pod, or maybe you are actually a container and it says still operation requires in order to complete the startup. So you have few startup stuff to be done for containers, and then that is like where it goes into waiting phase, right? So and it stays in waiting phase until unless that prerequisite is being set. For example, you can say maybe it is your application takes time, and it actually needs some other prerequisites to be done, like maybe DB connecting. It actually connects to a DB, and then only starts. That it can be that phase, and after that it goes into running phase. Running phase is like it actually starts, and all your prerequisites it's being fulfilled, and it starts exposing. Maybe it starts running on certain port, and it moves to that particular state of a container, right? And then it goes into terminated phase. So waiting is like your pod is in pending phase, your image is being pulled, and after pulling, maybe before pulling you apply some secrets, or maybe you log in to that container registry, and then after that your image is being pulled, and after pulling the image you're doing maybe you are trying to connect to DB, and you're going to check if DB is up, and then only you are stating. Until that point of time it is stayed in waiting phase, and after that all prerequisites are fulfilled, then it goes into running state. And the next state is terminated state. The container in the terminated state began execution and either ran to completion. So maybe like your execution is begun, or maybe it ran to completion, maybe it is completed, whatever task was there. And that's where it goes in terminated state. So that terminated states can be a failure or a succeeded. Now it comes, another thing comes called container restart policies. Okay, so what are container restart policies? So mostly we might have seen in that pod spec, when you see like we have a API version, kind, metadata, and then we have a spec. In that spec we have image, name, and some other stuff, and there is also one spec called restart policy. Restart policy means if you have a pod and you have a restart policy is specific to pod, and then when you have define a restart policy to a pod, it actually applies to all the containers inside the pods. And after the containers in a pod exit, the kubelet restarts them with an exponential backoff delay. So you say that, okay, for some reason your pod is terminated and you want to restart it, depending upon what restart policy you applied, then your actually your pod gets restarted by your kubelet, and it follows some delays like 10 seconds, and then after 20 seconds and 40 seconds, and then till 5 minutes. Yeah, so these are like this is like restart what are like container restart policies. And then when you talk about little in detail about container restart policies, so there are 3 restart policies, container restart policies. They are always, on failure, and never. So if you specify never, your container is never going to be restarted depending upon. So we need to have this container restart policy depending upon certain criterion. So for example, you say that you have some probe, maybe we're discussing in coming sections, then we actually attach that probe to certain restart policy. So if you're familiar with systemd, this becomes very familiar with you. So in systemd also, if you have a process and then you say your process gets restart when it fails, or then it becomes it specify that on failure stuff. So whenever your process gets down, or maybe it gets killed by some reason, it's restart by itself. Yeah, so moving forward, we are going to talk on container probes. So what are container probes? Container probes. So we already understood what containers are. We are going to understand what probes are. So probes actually means diagnostic, a check, periodic check, which is in this case, if we talk about container probes, the kubelet actually performs a periodic check on container. So it just checks, oh, okay, if my container is up, if yes, it's fine. If not, then it does something at the backend. So if your periodic check by Kubernetes kubelet to a container actually has some results. So for example, if it fails, then what it does, so it actually calls the handlers. So what are handlers in this case? So handler means you are actually doing a specific action. For example, you have your success. If you have your you are actually checking the probe of a container. You're just checking container is up or not. If container is up, then it's okay. If it is not, then what do you do in this case? So that is a specific action which you're going to which is actually handler is going to take care. So there are three types of handlers. One is exec action, second is TCP socket action, and third is HTTP get action. So these are 3 handlers which are actually which act on your probes. For example, you have a probe, and then after your probe is, depending upon the result of your probe, these particular handlers are configured and called. right? So whenever you do your probe, right, so every probe has 3 results. So one being success, failure, and unknown. So we understand success, non-zero, non-zero, like 0 exit status, 0 as a exit code. Maybe in this case, if you have HTTP GET action, you have status codes 200 to 400, and then there is a failure if it is like, if it's not following as defined, and there is unknown. So when you have success, you don't have any handlers called, maybe you can actually do it. And when there is a failure, then you attach a handler. You actually say, this is my handler, this is my exact action I need to perform a probe. And if this particular handler, if this particular probe which is executed by this particular handler is returning this success, then it's fine. If it's returning failure, okay, then I attach it to container restart policy, which we actually saw. So container restart policy are 3: always, never, and on failure. And by default, it is the restart policy which is attached to our pod is always. Yeah. Okay, so now coming to the probes, there are 3 types of probes. The first one is liveness probe, second one is readiness probe, and third one is startup probes. And so talking about the first one, liveness probe. So if you guys are familiar with the load balancers, so they have things called health checks. So in this, we can actually compare this particular concept with those health checks in load balancer. So liveness probe, as the name suggests, okay, we are going to check if my container is live or not. So probe is like we're going to check, and liveness is like we're going to check if it is live or not. So live means if my container is exposed to certain port, or if it is following certain criteria which we define by a handler. So that handler can be exec action, it can be HTTP GET action, or which can be a TCP socket action. So for example, you have some kind of a container where your application is writing a health check of that application in certain files. So you can actually have action to verify running some command, and if your command is returning as like success, then it is like your success. If it's not, then again, if it is failed, so one of your probe goes to failure, then failure is attached to your restart policy, which is by default always. So what it does, when actually your liveness probe fails, then your container restarts. Then your Kubernetes goes and restarts a container and again checks the liveness probe, and it keeps restarting your container in that back off delay, which is 10 seconds, 20 seconds, and 40 seconds, till your probes gets success. And then if it does not get success, then it goes into crash loop back off. That's one of the conditions. And the second is, and one more thing to note is that your liveness probe is directly attached to your container restart policy. So if it is not successful, then it is going to call your container restart policy, and container restart policies attached. It is for all the containers inside the pod. Then there is called readiness probe. Now this probe is to check whether my container is ready. That means if it is ready to serve a traffic. So how it works is like, it again works in the same way as your liveness probe works, but in this case it does not restart your container. It's just that it will if your probe fails, your container on which your pod on which your probe fails, it does not receive a traffic. So how does it achieve? So this is achieved by when you have this particular probe failing, and then what happens is like your IP of your pod is removed from the endpoint to which your pod is attached. So when you create a service, you have an API, you have endpoints, and depending upon your label, it actually gets your IP in that endpoint, and your endpoint is attached to service. And in this case, if your pod fails, this readiness probe, your IP is removed. So that makes sure that if your container is failing, it does not receive a traffic. Yeah. And there's a third type of probe called startup probe. Startup probe is the probe which is run at the very first probe to be run among these. Yeah. And until unless this probe completes, none of your probe kicks in. So none of means in this case liveness probe. So after first thing is run, which is liveness probe, and then readiness probe is run at the last. So here this type of probe is for applications which takes too much time to start. So you actually specify a few parameters like what are the period seconds, what are initial delay seconds, what are failure thresholds, what are successful thresholds. So these few parameters are specified to all the probes, and startup probes, as in it is not actually attached to any of the restart policies, container restart policy, and it is just to assure that, for example, you have liveness probe configured and then your application is taking too much time to come up, and then what happens is like your liveness probe keeps on restarting your applications in certain period of time. So that causes a problem for application taking too much time to restart. So this particular probe comes into that picture, and it does not until unless this particular probe passes, none of your probes kicks in. Hello guys, welcome to the demo section of container probes. So we start our demo by creating a folder called probes-demo. We go inside of the folder, and first thing we do is we just check what all namespaces we already have. So we do that by kubectl get namespace, and as you can see, we don't have an extra namespace. So first thing we are going to do is we are going to create a namespace which we are going to use that namespace for this particular demo. So kubectl create namespace, and namespace name will get our namespace created. And the second thing we're going to do is we're going to switch to that namespace so that we don't have to use -n option again and again. So that we'll do by kubectl config set context -f current -f namespace equals to the name of the namespace, and this will actually switch us to that particular namespace. So if that command is successfully executed, which it is in our case. And the third thing we're going to do is we're going to create a folder called liveness probe. So we create that folder by doing mkdir liveness probes, and we go inside that folder, and again we create another folder called exec action, as we have three handlers which we are going to use it for liveness probe. First one is exec action. So now here we are going to create a pod.yaml which will contain the pod configuration of this particular demo. So this is how your pod configuration looks like. This has image, name, a command, and also liveness probe. It has an exec, and there is a command which we are executing /cat/tmp/healthy, and there is something called failure thresholds, period seconds, successful thresholds, timeout seconds, and initial delay seconds. So these I already have explained it in our theory section, and we just save and quit. So since we have already switched the context into our current namespace, that is probes-demo, we can just check it. We don't have any resources created. So first thing we're going to do is we're going to create a pod. So we can do it by either create kubectl create -f and file name, or even we can do by kubectl apply -f pod name. So when you do kubectl get pods, it will give us the pods currently we created. So we can see that there is a pod liveness-exec, and it is in container creating state, and after some time it goes into running state. Yeah, and then we wait for some time, and we see the status of the pod. Again, it is in running state, and it has become 45 seconds. So we are just going to check what is the liveness probe, what it is going to do for us, and then how it works. So as we already saw right in the pod definitions, we have a command which creates a file called healthy in temp directory, and after 20 seconds of its creation, your pod is being deleted and your pod sleeps for 600 seconds. So ideally, after some period of time, your pod is being created, and after creation, after 20 seconds of your time, and depending upon the failure thresholds, success thresholds, and all other parameters which you have defined in liveness probe section, your container restarts. So as you can see, your container is restarting after 2 minutes 6 seconds. So that is when your file has been deleted, that is temp healthy file. This has been deleted, and then these are few things like, so as you can see, initial delay seconds. So after your pod is created, it is waiting for 5 seconds, and after that it started doing probes. And after it starts doing probes, there is a regular interval which is represented by period seconds, and after that there is a successful threshold and failure thresholds. Depending upon it, actually decides whether your container is healthy or not. And if it is not healthy, what it will do, it will go ahead and restart your container. In this case, if it is restart my container, it is not gonna find my temp healthy file. So every time it is going to keep on restarting my container. So this is actually useful when you have your pod when you have your pod and it has a container inside it, and it fails for some reason, and then just to give a feel of a selfie, as you can see, it keeps on restarting, and it has become 3 times restarts. So this is the first thing for exec action. So what we'll do is we'll just go ahead and clean this pod. So that we do by kubectl delete pod. In my case, I'm doing -FN all, so you should avoid doing that. I did it because I have only one pod in this namespace. The second thing we're going to do is we're going to go back one step behind, and we're going to come back in the folder called liveness probes, and we already created a folder called http get action. That http get action is the second it's a second handler which we are going to use it for liveness probe. So again, we are creating a pod definition for this particular probe, and then it's similar as we have created. So it has API version, kind, metadata, and here we are going to name the kind of a pod as liveness-http get action. So that we do by this, and then we have a spec, and in the spec we specify these particular configurations, which has failure thresholds, period seconds, and the only difference is like liveness probe has http get, and in that we mention a path and also a port. So in this case, port is a port which we have defined in the container section, so it's a named port. Okay, and then now first thing we're going to do is we are going to move that pod into the correct directory. So we did it by mv, and we are going to just check if we have any extra pods. So ideally, as per our definition, as per our cleanup, we should not get any pods. So now we're going to create a kubectl apply -f, and then oops, we got an error. Okay, looks like there is some issue with the naming convention. So I go ahead and I think it looks good, but yeah, I'm going to make it start. So sc port, and I'm going to save and quit. Again, I'm going to apply it. Again, I get this error. So invalid name liveness http get action must contain lowercase. Okay, that is the problem in the name of the pod. So we go ahead inside the container again. File again, and we are going to I think I was editing the wrong file and the wrong place. So it says liveness get action DNS 1123 subdomain consists of lowercase. So this is the place where I think I should actually go ahead and edit. So ideally this should get me things working now. If it is not only pod, okay, your pod name also should be this, like should follow the same thing. So it should be all lowercase. Yeah, ideally it should work now. Yeah, what we have done in this particular pod specification, as you saw, we took another image. That image is a node image which has a health check. So when application starts, there is a health check API which runs on /etc and on port 3000. So as of now, there is no failure and my application is healthy and on a port 3000. So now we gotta do a change and check. So we have done a change, and we should actually in pod we should actually first delete the pod and then create a new one to see our actual change which we just applied. So we gotta delete it. We should do that kubectl delete pod and give a pod name. It is successfully deleted. Now we are going to create a pod which we actually with a new configuration which we just changed. So we did it by kubectl apply -f pod.yaml, and we should get our pods up. So that we do by kubectl get pods. So currently it is in container creating state, and we do kubectl describe pods. In this case, I'm not putting the name because there is a single container. So it says my pod is currently created, and after some time, depending upon what specification I have mentioned, so it says that liveness probe failed. So it actually does it does HTTP and then IP and then 3000 HC and then checks the status, and after that you could see there is a restart, and your container keeps on restarting until and unless your probes gets correct result. That is, like, it should get a status code of 2000, somewhere between 2200 to 400, so that for your pods to become for your handler to get a success, for your probe to get a success result. So now what we're going to do is we're going to just clean it, and again cleaning this we can do it by kubectl delete pod and give the pod name http get action. Okay, so again coming back to the third, coming one step behind, and we're going to create a new file called tcp socket action, tcp socket action. Now we go inside that folder and we are going to clear a screen, create a pod.yaml, which follows the same configurations, but the only difference is we will have a liveness probe difference. So it is similar, like we have API version kind metadata, and we are going to name this as liveness TCP. We are going to have all name of our pod as all lowercase, and we're going to have a spec contains containers, we have a name of the container which should be similar, and we have image which is similar, which we use, and this is how it looks like. The difference is, like, you have TCP socket action. So TCP socket actions only needs the port. So TCP liveness probe TCP socket action, and then you give a port. So in this case we have named that port, and we already also checked we don't have any containers because we deleted, and now we're going to create a new one. So we can do it by kubectl apply -f port.yaml. Okay, so there is a small typo error. I think that's the name. The name of that object should be in uppercase. I delete. Now it should work. kubectl apply -f pod.yaml. Okay. You need to kubectl get pods. You have this pod being created, and we do get pods, and there is no restarts because it is running perfectly fine. It is trying to check if your 3000 is a port which is mentioned, which is over here, it's perfectly working or not. So you have a liveness probe. You have 3 failure thresholds: initial, delay seconds 5, period seconds. After every 10 seconds it will check, and then it will check for the port which is 3000, and we have named it as a HC-port. Yeah, so that's it for this demo, guys. Yeah, and you just go ahead and describe and check, and then it'll actually, if you have a wrong port configuration, it'll actually be attached to your container restart policy, which is always in this case. Hello guys, welcome to the demo section of readiness probe. So we'll start the demo by creating another folder called readiness probe, and we'll go inside that folder, and after that we're going to create one more folder called exec action, and likewise we'll be creating 2 other folders which will be actually representing the handlers. And now what we are going to do is we're going to create a deployment, and we do it by creating it a pod specification in a YAML file. So we can just go ahead and do API version as apps v1 kind is a deployment. We give a metadata, and we give a name called rexec. Rexec is R for readiness probe, and exec is for using exec handler. So now after this specification, we are going to use nginx as a base image, and we're going to execute a small command that is touch. We're going to create a file called healthy in temp directory, and we're going to sleep for sleep for some seconds, like 40 seconds, and then after that we're going to remove that file, rm-rf. It's similar what we did in our last section. Last video we did the same thing. So we are going to do like this, and then we're going to sleep for 600 seconds, that is 5 minutes. Now we're going to do a readiness probe definitions. So it's similar to as what we did in earlier. So readiness probe exec, and we're going to use a command, and then command should be cat. We're going to check if that file exists, and if that file exists, it will say exit status will be 0, and that is success, and if not, then that is failure. So what we want to do show here is like your readiness probe is actually attached to your endpoints, and your liveness probe is attached to your CRT. Now since we have deployment created, so we are going to create a service, because we want to get a demo on what actually endpoint looks like, because service attaches to an endpoint. So we go ahead and create a service. It looks like this, and then we're going to give a port called 80. So 80 is a target port for our Nginx. And similarly, we'll make sure our selector matches the correct deployment. So first thing we're going to do is we're going to create a service. It's always good to create a service first and deployment later. So oops, we have some error. So I think we missed the port definition. So we'll go ahead and create a port definition, that is a service port. We'll go inside the container. We'll go to the file, and we will say port. Let's say we have a port called 9000. It should work. Oh, we have a YAML error. Okay, so we'll go inside this, and ideally it's not like this. We'll just make few changes, and it will be like in this level. So there is a syntactical error, and we'll just correct it, and then after correcting it, we'll write and save, and I will apply it. So applying this will get us a service created. We can check the service kubectl get service, get svc. You can see there is another exec, and if we do kubectl get endpoints, so as you can see we have no endpoints, because we have no pods created as of now. So now what we're going to do is we're going to see this. If we have pods, we can see there are no pods because we didn't create it. So kubectl apply -f, when we do deployment.yaml, then it will create a deployment, which will in turn create a pod. So there are two replicas, and they're in creating state, and after some time, as you can see till now, since their status is not one-on-one, that's the reason they have not been added to a endpoint. So because the readiness probe is not passing for some reason, and the reason is like, we can just go ahead and check again endpoints. So see, still we can see. So one thing we can do is we can just go ahead and check endpoints now. So it takes time. Then now we can see there are two pods, and both the endpoints are being added to our endpoint section. Yeah. So this is happening because our probes are passing, and after some time, as we have actually written into our pod arguments in definitions. So ideally it should delete my healthy file, and after it deletes the healthy file, the healthy file in /tmp, it will start failing. The readiness probe should start failing, and once readiness probe start failing, it will start removing the pods IP address from the endpoint. So when we do again get pods, we can see still we have our stuff healthy, because it actually works on the parameters which you have mentioned, and as of now we can see one of our pods, the endpoint, it has been removed from the endpoint because the probes started failing for that pod. So it is as simple as that. So it's just the definition between readiness probe and liveness probe is like readiness probe is more attached to your CRT like endpoint, and your liveness probe is more attached to your container restart policy. So what we'll go is we'll just go ahead and delete the deployment, and we'll just clean up so that we can go ahead and move to the next handler, that is HTTP get action. So for that we are going to create a folder called HTTP get action inside readiness probe, and we're going to copy the files.service.yaml, and also we're going to copy the file or deployment.yaml in http get action. So as you can see, so just to like eliminate the extra effort. After copying, when you do, we'll just go inside this and we'll just change the name of the service just to make sure it looks like appropriate, and just to avoid confusions. Also the labels we are changing. Similarly, we'll go to deployments and we'll do the same changes. So one thing we'll do is we're going to remove this arc section, and we are going to add a named port. So we are going to say that we have a port section. In that port we are going to give a name, HC port, health check port, and the container port for our, as we already know, for Nginx is 80. So this is my port, and that is the port name called HC port. And another thing we'll go ahead and remove the exec action. We are going to put http get action. So for that, in that readiness probe, what we'll do, we'll just say http get, and http get action needs few things, that is path and port. So path is / and port is the port, and there are a few other directives like initial delay seconds, period seconds, timeout seconds, and success thresholds. And there are some other things we're going to change. We're going to change the labels, we're going to change the container name, and labels is like very necessary because like service will select on the based on top of that. Yeah, and here also we'll got to change the name of the deployment so that we have a uniformity across. We are also going to delete the service which we had created for our exec, so that things we start as a fresh. Our service is deleted, and first thing we're going to do is we're going to create our service which we newly created, that is our HTTP, and we're going to just check if we have our service created, and it is created successfully. Now let's check the endpoints. We don't have endpoints. Obviously we should not have endpoints as of now because we didn't create any pod as of now. So when we create the pod as a pod, so you're going to create it using the YAML which you have described, and after some time our pod should be created. They should be in running state, and after being in running state they should be actually added to the endpoint. So when we saw it, they were already added into endpoints. Yeah, and yeah, so now what we're going to do is we're going to actually add another section called liveness probe. So as we already have seen, right, so what actually happens when we have readiness probe, so readiness probe, what it does, it actually removes if you have like if a probe is failing, and it will remove that particular pod from the endpoint so that it doesn't receive the request. So now what we want to configure is we want to configure liveness and readiness both. So we want to make sure that if until first the order in which it kicks in is like first liveness probe kicks in, and then if my pod is unhealthy, if it is not passing the probe, it will actually restart that container, and after restarting, if it comes up, then only it actually goes for the readiness check. So actually we can have both checks like liveness probe and readiness probe to use the same handler and to actually use the same condition. So we can do it like that. So in this section we actually saw, right, so we actually changed the port, and after changing the port we could see there was like a new pod coming up, but it was not being added to the endpoint because it was the readiness probe was failing. Yeah, and so one more thing we have is like, so we have a problem called we need to have a success threshold at least one success, and after that when we actually apply, and when we there is an error image pool, maybe an internet issue, usually it happens. So sometimes I have an intermittent internet issue problem, so maybe I can go ahead and just do kubectl describe and check what actually is happening behind the scenes. Okay, so it says that it has already started the container. So when you see 0 of 1, that means the probe readiness probe is not passing yet. And then if you can see, your containers also have been started because you have your probe failing. The first probe is like you have changed the port number, and then after you have applied, the first thing which kicked in was a liveness probe, and because of which it actually failed, and because of which it restarted, because it was not actually correct port which was configured, and that's the reason it was restarting the container again and again, and then it was not actually going to the readiness probe. So now when we actually correct it, so what it will do is it will actually first go ahead and check the liveness probe, and if liveness probe is fine, depending upon the different parameters which we have mentioned, so then what it does, it actually rolls it out. So it actually goes for the readiness probe, and then when readiness probe is also passing, then it will actually go ahead and add that particular endpoint in that particular IP and port in the endpoint of the service, so that it can actually receive the new traffic. So we can actually use both readiness probe, liveness probe, and then that will actually help us to check both resiliency, and also it will help us avoid our faulty container receiving the traffic and getting errors. So now we're going to clean up this section so that we can move to another section, and that is called TCP socket action. And after cleaning up, let's check if we have any resources available. So as you can see, we don't have, so kubectl get all will give us. Now we'll go one step back and we'll create a folder called TCP socket action, directory called TCP socket action. We'll go inside this TCP socket action, and we should copy the deployments, YAML configurations which we created in this particular demo. So all we have going to do is we're going to change the name of the service, and we are going to change the name and change the label selector. So we have an app called app label as a HTTP. We're going to make it to RTCP. And similarly, we are going to change in deployment.yaml. So a few things which we are going to change is the name of the deployment, obviously, to make it uniform and make it clean, because to avoid confusions. And few more things which we're gonna change is we are gonna change this handler, so it should be TCP socket, and TCP socket only needs port number. So we have port number, and then we are going to have period seconds, so we can actually tune it according to our use. So let's say it waits for 5 seconds, and after 5 seconds it starts actually checking the probe in every 20 seconds. So after that, we are going to actually create the service. Once we create the service, we are going to also create the deployment after making the suitable changes. And when we just go ahead and just check, similar check we are going to do is we're going to check if we have SBC is properly created, if we and if we have pods properly running in a learning phase. And then as you can see, they are still waiting for probes to pass, and after probes are being passed, they are added into endpoint. So since they are added into endpoint, they should have passed all the probes. In this case, there is a readiness probe. So one more thing what we can do is we can just go ahead and just change this, and after changing it, when we actually apply it, it will actually create a new pod, because there was a configuration change. And then after that pod it will start actually checking for the probe, readiness probe, because there is no liveness probe. And then since that pod is not passing the readiness probe, it is not adding that faulty pod to the endpoint. So as you can see, there are only 2 pods which was actually initially there. So the IP being 10.42.0.5 and 0.6. So we just do, when we use -o option, it will give me the IPs as well. So there is the new pod which has an IP called 7 that is still not added because it is failing the probe. The idea behind is just to make it clear that readiness probe is attached to the IP, attached to the endpoint. Now, so this is how it looks like. So we can actually combine liveness probe and readiness probe together, so that with any of the handlers. So as to make sure that we can have same handler, same condition for liveness and readiness probe. So to make sure that your container is restarted, and then it actually is healthy. After being healthy, then only it goes for readiness probe. So just for that, we can actually have same definitions of the probes for both. And when we apply this, so after applying it, we actually saw, right? So we actually created pod with the wrong configuration, and then when we actually push the same configuration with the liveness probe with readiness probe, so first thing it should do is it will keep on restarting. So it will keep on restarting until your application becomes healthy, and after your application becomes healthy, then only it has the readiness probe kicks in. So you can put extra probe on. So for example, if your application is healthy, then on top of that you can have another extra checks to make sure your readiness probes are correct. So as you can see, right, so liveness probe is kicked in first, and after some time your readiness probe is also kicked in, right? And then this is how it works. So similarly, as we saw in HTTP GET action, we also saw in TCP socket action. So yeah, so now what we're going to do is we're going to just remove this. We're going to clean it up. After cleaning it up, we're going to see the third one, that is called startup probes, and we already saw the definitions and the theories in our in your beginning sections. So that's the reason I'm not going much into theory over here. So for startup probe, what we're going to do is we're going to come 2 steps back in the folder called probes-demo, and we're going to create a folder called startup probes. And in this probe, we are going to just see one implementation of the probe, startup probe, that is HTTP GET action. We can actually do similarly for exec and TCP socket action depending upon the use case. So in this case, we are going to create a HTTP GET action folder, and in that GET action folder, we are going to have the like YAMLs which describes the pods. I mean, which describes the deployments, which actually describes the pod. So that we can do by copying the YAMLs from readiness probe, which we recently did. We can copy everything from there and put it over here and change few things. Let's change few things. We go in the service, then we just change it R to S, and after that we are going to deployment.yaml, and we are service.yaml, we are changing R to S. Yeah, and after that we are going to deployment.yaml, and we are going to change R to S, and we are going to add one more probe. So we want to use all 3 probes just to understand what is the order in which they kick in, and then what is the use case. So startup probes are used for the slow starting applications. So what happens, like you have an application, it takes time to start up, so your startup probe is for them, and then until unless your startup probe succeeds, your liveness probe doesn't kick in. So since liveness probe doesn't kick in, it doesn't restart your application. So you can understand that your application is taking slow, it's taking time to restart then and in meantime it comes, your liveness probe kicks in, so it keeps on restarting your application and it goes into deadlock. So there is another way you can actually wait for, you can have an initial delay seconds of some time, and then actually achieve this, but that's not a proper way. And you have startup probe, and then you specify conditions, and when it passes that condition, then only your liveness probe kicks in. So after making changes, we can just go ahead and apply both the files. So okay, yeah, there is some configuration, there is some problem, failure threshold seconds. At least that is failure thresholds. So failure thresholds in startup probes is like how many what is the maximum amount of time it can fail. As in this case, it is like 6 times. That means 6 into 10. So 60 seconds. There's a buffer time for an application to wait, and plus initial delay seconds of the liveness probe. So only after that your liveness probe kicks in. So it's like 60 seconds plus the initial delay seconds of your application, of your liveness probe. Your application gets time, and it comes up. So it actually gets a more proper amount of time, and then yeah, so it gets what we wanted to achieve. So if you can see, right, so we have since there is no problem, our startup probes passed and things started going well, so there are no logs. So now what we go ahead and we just do one small tweak, that is change. We change this and let's see how it behaves. So the order is startup probes is the first which gets kicked in, and after kicking, startup probe is being kicked in. Ideally it should check for 6 times, and after that fails, then your application gets restarted. And if it passes, your application doesn't restart, it goes for readiness probe. And if your readiness probe passes, it adds in. So as you can see, it has been 3 times it has been checked okay, and then your probe is failing, your startup probe is failing, and then ideally we have mentioned the failure threshold as 6, so it should check for 6 times. So 6 into 10, that is like 60 seconds. So if you can see, it has checked for 5 times and it has taken 47 seconds. So now the third one, when you checked it, we can say it has approximately 60 seconds. So now your readiness probe should kick in. Container started and your startup probe failed, and after your startup probe being failed, your liveness probe should kick in and it should restart your application. So as you can see, your application is being restarted. Yeah. So this is how it works, and then maybe you can actually try other ways, and then you can actually just go and check how it looks like. And then when you do describe again, so you can say you have your readiness probe still not kicked in, and then because the liveness probe is yet to kick. Do let us know if we missed something and we can actually improve on something. Thank you guys.